Good evening, students. Today we are going to continue with the topic covalent bond, and after that we will start with the other property of carbon like allotropes, catenation. Further, if the time permits, we will discuss about the isomerism. Students, continuing with the covalent bond, we have started last day and we had learned that this covalent bond is formed by sharing of electrons, and this sharing is always occurring in equal number, means equal number of electrons have to be shared by both the constituting atoms. That is one thing. The other one, like last day we have discussed about this, say if we consider the structure of CO2, here we are observing carbon have shared 2 electrons with the oxygen on the right hand side, and the 2 electrons of right hand side oxygen is also being shared by this carbon. So this way total 2 pair of electron is shared between the carbon and one of the oxygen. But for completing the octet, the carbon need the 8. So that's why it also shared 2 other electrons with the other oxygen. By this way, we are observing that the shared electrons are under control of both the atoms, and these shared electrons are counted twice, means once for each atom. So for oxygen, if you want to count the total number of electrons, then whatever the red electrons which are inherent to the oxygen, that we have to count, and the shared electrons mean the 2 blue electrons. So this one. So this way the total, say for this oxygen, if we are considering, we are able to get total 8 electrons, the 6 black one and 2 blue cross. So total it become 8. So this way 8 electrons with this one. Again consider for the carbon, you are getting that total 4 blue cross electron for the carbon and 4 other black electrons of the oxygen, 2 electrons from each of the oxygen. Same is also holding good for the other oxygen. So this way the octet of each of the atom is completed. Also, how much pair is shared? So each pair is forming one bond. So it is one of the bonds. Say if you are considering the electron of carbon with the electron of oxygen, it is forming one bond, means one link. Similarly, the other link with the same oxygen, the other bond. So it is basically the double bond, though covalent but doubly linked, so it is called the double bond. Can we say carbon is forming triple or quadruple, means the 4 bond or 4 pair of bond? A student, if we count the carbon, then we are observing this carbon is forming total 4 bond. But the type of bond like single bond, double bond, triple bond is looped between the 2 atoms. So the type of bond here is the double bond, and this double bond always have to be looked in terms of the 2 atoms. So either you will look carbon with the oxygen on the right hand side, or you will look this carbon with the oxygen on left hand side. Here we are getting with this carbon which is in center with the oxygen on left hand side, the 2 bonds are formed. So it is the double bond. So single bond, double bond, triple bond always means between the pair of atom. That we have to keep in mind. Because this single bond, double bond, triple bond we are going to use in our alkane, alkene and alkyne. So those structures are very important. Again, considering the carbon and oxygen on right hand side, again the bond formed is 2. So this 2 bond is also called as the double bond. So how much pair of electrons are shared between the particular 2 atoms? That gives the type of bond. So right hand side it is also our double bond. Though carbon is forming total 4 bond, so you cannot say it is 4 bond or say single, double, triple, say quadruple. Means 4 means it is called as quadruple. So it is not the quadruple bond. It is only double bond. Though carbon is forming 2 double bond. One double bond with one of the oxygen, another double bond with another oxygen. So single bond, double bond, that we have to be observed with reference to 2 particular atoms. Now if we come with the carbon and hydrogen in the structure of CH4, here we are observing only one pair of electron is shared. So number of shared pair gives the type of bond. Student, if the number of shared pairs we are always looking, if it is only one, then we call this as the bond as the single bond. So if the shared pair is one pair means 2 electrons are shared only. Means it is 2 electrons are only. Here we are getting consider the carbon and hydrogen only. Here we are getting 1 electron is this one, blue one, another electron is this black one. So 2 electron, it is just forming 1 pair. So this is forming 1 pair. Are we getting? So it is like this. So this 1 pair, such a bond is called as our single bond. Sorry. So here the single, double or triple have to be observed between 2 specific atoms. So here we need to consider the carbon and this hydrogen, and here we are getting only 1 pair of electron is shared, or only 2 electrons are in the shared region. So therefore this bond is called as single bond. But in CO2 we were observing that 2 pair of electrons, it is called as the double bond. So if shared pair is only 1, means 2 electrons are shared between these 2 atoms, it is called single bond. This term we will use. So it is single covalent bond or single bond. If the shared pair is 2 in number, 2 in number means total shared electrons will be 4 electrons are between this shared region. Say let us consider the carbon and oxygen. What is this shared region here? A student, here this shared region is like this one. This is our shared region. This is the shared region. So in this case, we are getting that in the shared region, we have total 4 electrons. 2 electrons from the carbon, 2 electrons from the oxygen. So if the shared region contains 4 electrons, means 2 pair, then it is called as the double bond. So to write this as the double bond. If it is 3, then it will be called as triple bond. If this is 3, then means 3 pairs. total 6 electrons will be in the shared region, then it is called as the triple bond. This we have to keep in mind. So how is the single bond, double bond, triple bond? Those things we are going to learn in a bit more detail. And this covalent bond can exist in the molecule even do not containing the carbon atoms. Means covalent bond need not mean always the carbon atom is present in that molecule. No. So the molecule without carbon atom can also form the covalent bond. Though this concept we have learned with reference to the carbons. Those things we are going to learn. A student, so regarding covalent bond, so covalent bond is formed by sharing equal number of electrons between the two atoms. That is one thing. These shared electrons lies under the control of both the atoms. So therefore, it have to be counted twice, means counted with each of the atom for considering their bonding, the type of bonding like single, double, triple, and the stable configuration like octet or duet. Okay, student, it is other thing. The example that we had taken like carbon dioxide, methane, ethane, all those things. We are going to learn a bit more about this thing. A student, the ultimate purpose is to form their octet, but hydrogen which contain only K cell, which have the capacity to accommodate only 2 electrons. So by getting the 2 electron in K cell, the hydrogen becomes stable. So these 2 electrons in K cell for hydrogen can be achieved either by gaining 1 electron or by sharing 1 electron. Because one of the hydrogen is sharing 1 electron, other electron will be shared by the other element, maybe carbon, like in CH4 we have observed, or maybe the other hydrogen itself, or maybe the chlorine itself. Okay, student? So those things we are going to understand in a bit more detail. A student, if we consider the oxygen, let us consider oxygen. So O2, how is the bonding? Say, if we consider the oxygen, right, their electronic configuration, only outermost electron we will write here. So the electronic configuration is like K and L, 2, and total 8 electron in this oxygen. So it will be 6 in the L cell. So electronic configuration wise, total there will be 6 electrons around this oxygen. So only 6 electron we are going to draw. We are not going to draw the 2 electron. So the electronic configuration, the outermost electron or valence electron we are drawing. A student, if we consider only one oxygen atom, then we are getting that it contains 6 electrons. But to be stable, this need 2 more electrons to achieve total 8 electrons in their outermost orbit. How they can do? So if there is other element which can give 2 electrons, then it can gain it and it becomes stable to form O2 minus. But if there is no other element like sodium or magnesium, they are called as the donor. If the donor of electron is not there in the surrounding of this, if there is other oxygen itself, then what are the possibility? Whether it can combine with the other oxygen atom itself or not. A student, consider these 2 oxygen. Now both of these oxygen are willing to have 8 electrons in their outermost orbit. How they can achieve it? Only oxygen is in surrounding. None of the oxygen will agree to give their 2 electron to the other oxygen. So the way or the method left is the sharing of electrons. So this oxygen will tell, I am also putting one of my electron closer to you. You also put another electron closer to me, and let us share one of the electron. But by sharing one electron, both the oxygen will not have the octet configuration. For that, they will also agree to share one more electron. So these two oxygen atoms will come closer, and what is going to happen? Let us take. Let me draw that figure. Consider this oxygen. For this oxygen, I am drawing their electrons by the blue dot. Consider the other oxygen. Their electrons I am considering with the black dots. Okay, student? So what will happen? These two will agree to share these two electrons. Means this will form one of the bond, another electron of the left oxygen, and this right oxygen. They will also share the other electron. So this way they will form the other bond. And by this way, these two shared electrons will lies under the control of both the oxygen. Means the first oxygen as well as in the second oxygen. So let me draw with the blue color the left oxygen. Let me draw the right oxygen by the black color. So the order or jurisdiction of this right oxygen will be up to the two shared electron by the left oxygen. Are we getting? So this way, the region or the area like this one, it will be our shared region. So it is our shared region now. So here we are observing that if we count the electrons for left oxygen, how much electrons are there? The student observe carefully. The 4 electrons which are not shared, these are called as the lone pair, but you need not mug up. And the 2 electron which was shared, but while sharing, 2 more electron also comes from the right oxygen and which is under the control of left oxygen. So for the left oxygen, we have total 1, 2, 3, 4, 5, 6, and 2 more shared, means 7 and 8. So 8 electrons are there. Similarly, for counting the electrons in right oxygen, we also need to observe the same thing. Means count it again. For the right oxygen, the number of electrons. So count it, student. Here we need to count the right oxygens. So count 1 electron, 2 electron, 3 electron, 4 electron, 5 electron, 6 electron, and 2 more electron, which is now coming under the control of right oxygen because of sharing. So total 8 electrons are also available with the right oxygen. So this also contains 8 electrons. So this way, both the oxygen attains the octet configuration. So this implies both oxygen attains octet configuration. And what is the formula formed? So to denote this in simple form, last day we have learned these unshared electrons are not written, and this shared electron is always drawn in paired form by one of the line representing one pair. So there is 2 such pair of sharing, so by 2. So this is the structural formula. And in molecular form, I mean the formula form, how to denote? Just write this as oxygen, and their number of oxygen is 2. So this way, O2 is stable and formed or found in nature, but not the O. So single oxygen atom you cannot get in air, but you will always get in the form of O2, because one of the O, even if it is formed, it will quickly react with the other O oxygen to form O2. O3 is also formed. That is another concept called coordinate covalent that you will learn in higher standard. So O3 we are not considering here. Where the concept of donating their lone pair arises. So a student, it was the formation of O2. So how is the structure of O2? If you need to draw, you have to draw this structure. So this thing you have to keep in mind. Now let us go for the other. Let us go for the N2. How is the structure of N2? How nitrogen is forming the bond. So students, let us go for the structure of N2. N2. How is the structure of this N2? Now you, a student, please draw the structure quickly. I will give you 1 minute. What is the method? The method is very simple. Write down the electronic configuration of nitrogen. So electronic configuration of nitrogen. For writing the electronic configuration, you have to first write their atomic number. Atomic number is 7. Forget the atomic mass. Atomic mass is not useful. Write down the electronic configuration. So K cell and L cell. K can contain 2. The remaining 7 minus 2 means become 5 will be in L cell. So this is the electronic configuration. But what is the stable one or required one? These have the tendency to have 2 electron in K cell, but 8 electron in L cell. So this is the stable configuration. So for a stable configuration, I need the 3 electrons. From here we can get either 3 electron is gained or 3 electron have to be shared. So that total 3 pair of electron will be shared. So write down the electronic configuration of nitrogen. 1, 2, 3, 4, 5. Another nitrogen. 1, 2, 3, 4, and 5. I'm just writing the valence electron. Now, both of these nitrogen want to have 8 electron in their outermost orbit. They want to complete the 8. So they will agree to share. How much pair they need to share? 1. By sharing 1 pair, only one of the electrons, say in left, you may count, only one of the electron will increase, though it need to increase 3 electron. So it will share another electron. By that, one more electron will be increased. So total 7. If one more is shared, then the 3 more electron will be available or will come under the control of this nitrogen. So how to write the structure? So structure is very simple. Let me draw the structure also. I'm drawing the structure here. So nitrogen and another nitrogen. So let me draw the electrons like this. Here we will share the 3. So I'm just drawing in the same line. For the other nitrogen, also we have to do the same thing. They will start sharing. One electron will be shared, other electron will be shared, this third electron will be shared. This way, these 3 electrons will get shared. So for writing that shared electron, let me bring it more closer so that I can draw the structure easily. Now the structure of N2, or for the left nitrogen, the area is up to this one, and for the right nitrogen, the area or the atomic size will deform and it will be up to this one. So this is the way. So we have to keep in mind for drawing the structural formula or electron dot formula. So representing the electrons in form of dot and writing their structure, it is called as electron dot formula. Electron dot formula. But for convenience of denoting, we are just leaving the unshared electron and drawing the shared electron with the help of horizontal line. So here we are getting 3 pair of electrons are shared. So 3 horizontal line have to be drawn between the 2 nitrogen. So this structure is called as your structural formula. Structural or bond formula. Or the bond formula, sometimes also denoting like that. But writing this in the simplest mathematical form or denotation by using the symbol, here we are getting this structure or this stable molecule contain 2 nitrogens. So nitrogen and suffix 2 is written here. It is called the molecular formula. A student, this structural formula, molecular formula important. Sometimes the molecular formula will be given. You have to draw the structural formula. So the ultimate purpose is to draw the electron dot formula. There, the octet of each of the atom should be completed, excluding the hydrogen where duet is required. So it is this way. So this way, N2 is adjusted. A student, now you people please tell me one more. How is this chlorine, Cl2? What is the structure of this Cl2? Yes, the student, tell me quickly. A structure of Cl2. A student, focus over the electronic configuration. Write there electron dot formula for one of the chlorine. Observe how much sharing is required. Bring it closer. Draw the formula or redraw the formula. Here, if we consider the chlorine, this chlorine have atomic number 17. So electronic configuration K, L, and M, because K can contain maximum 2, so 2 is okay. L can contain maximum 8, it becomes 10, but 7 more is there, so this 7 is here. So these have a tendency to get converted into KLM, with K remains unchanged as 2, L unchanged as 8, but M also have to attend the 8. For reaching from the 7 to 8, 1 electron is required to be shared or to be gained. So this gaining is possible, say if there is Na and Cl, then we were observing it was able to give 1 electron and this was able to transfer with this one, and Na plus and Cl minus formula was formed. But if sodium is not there, if only larger amount of chlorine atoms are there, then how this octet can be achieved? For that, again take this chlorine, draw the 7 valence electron. 1, 2, 3, 4, 5, 6, and 7. Take the other chlorine. Draw their valence electrons. 1, 2, 3, 4, 5, 6, and one more have to be drawn. Let me put it here, 7. Here we are observing already it contains these 7. Consider any of the chlorine, you are observing already there is 7. So to become 8, it need to share only one of the electron. So for this left chlorine, we have total 8 electrons. 7 their own and one more is being shared. For the right chlorine, again the atom will extend their boundary and reach to the shared area. So this way we are observing only one pair of electron is shared. Pair of shared electrons. So one pair or 2 electrons in shared area or shared region. So wherever only one pair is there, it is called as single bond. So single bond. And denotation, chlorine and chlorine, only one electron is shared. So it is like simple. Finally, the molecular formula will be our Cl2. So here we are getting that if we consider the chlorine, say Cl2 and O2 and N2, then we are observing that between chlorine and chlorine only one pair of shared electron. Between 2 oxygen there is 2 pair of shared electron. Between nitrogen there is 3 pair of shared electron. Okay. So between chlorine, oxygen and nitrogen, what is difference? So this question is also asked in your NTSE and other. So the type of bonding, though all are covalent bond, but the first one have single covalent bond, single covalent bond. The second one have the double covalent bond, but the third one have triple covalent bond. Okay, student. So this way we have observed even the molecule which do not contain carbon, they are also able to form the covalent bond. A student, can you people tell me for this one? Say how is this HCl? Say for H and Cl, how is the structure? What are the possibilities? Yes, student. If we consider the hydrogen here and chlorine here, the hydrogen have only one electron. But if we consider the chlorine, chlorine have total 7 electrons. In this case, we can think in 2 lines. One is hydrogen may give 1 electron to chlorine and become H plus and Cl minus. The very first possibility is hydrogen get converted into Cl plus by losing 1 electron, and chlorine gain that electron to become Cl minus and HCl is formed. So it becomes ionic. You can say this is the ionic bond. But many theories suggest that or tells that this hydrogen have 1 electron and it need 1 more electron. then why this hydrogen shall give one electron? So rather than giving one electron, it is also possible that if one electron is shared by the other atom, you can form the covalent bond also. So the other way is, see, this hydrogen will come closer to this chlorine. So draw it. The chlorine, draw the bond of chlorine. Draw one more. So hydrogen will extend it, because for hydrogen stability it need only 2 electrons because it contains the K cell. And for the chlorine, now the available electrons are 8. So this way a bond or covalent bond is formed between this. So this way this H and this Cl is formed. So what is true? Whether first mechanism of forming positive ion and negative ion, that is true, or this shared bonding, this is true. So which one is true? Practically it is found that these HCl have covalent bond, but they are ionic in character. So more detail you will learn in higher standard. That kind of bond is called the polar covalent bond. See, why is that? So hydrogen and chlorine, though they will share the electron, but this chlorine have more tendency to pull the electron. So therefore the electron which was shared is now more closer to the chlorine and slightly away from this hydrogen. So this hydrogen electron, though it is shared by hydrogen, but under more influence or under more control of this chlorine. So in this case, it is found that hydrogen carry certain amount of positive charge, not the complete positive charge, denoted by delta plus. And this chlorine also carries certain amount of negative charge, not the complete, because it is not complete transfer, it's still sharing, but more domination of chlorine. Like say two students, say one is very intelligent or very smart or say slightly clever, and another one is not that much clever. Though both of you have shared 50-50 rupees for buying the toys, but the clever one student or clever one friend will use that toys for more time or longer time. He will feel that, or the other can say, yes, the one who is using it for longer time, so more ownership of that person. So it is like that one. Though the electron is shared one, but chlorine have dominant effect. So while the chlorine have more domination over the shared electron of hydrogen, it will gain some negative charge. So such kind of bonding is called your polar covalent bond. So it is polar covalent bond, and this is the true structure of HCl. Though it is having the charge, means they can conduct the electricity in solution state, but this bonding is still formed by sharing of electron, because total transfer, for the total transfer, if the sharing is or the possibility of sharing is available, then total transfer is not preferred by any of the atom. So it is rare. Ready? So this is the correct structure of HCl. Even the bond is this one. So this is the preferable. So likewise, there are many other compounds. No need to go in all those. I think this much is enough.
Sir,
Any student have any doubt, then ask. Yes, Neeraj.
sir, a covalent bond is stronger or ionic bond is stronger?
A student, ionic bond are the bond between opposite charge. Are you getting? So opposite charge means there is more attraction, but covalent bond is just an agreement. So covalent bond is lesser strong because electrical force are more stronger than just sharing. So you may write that one also. Ionic bond have very strong electrical. It is basically the electrostatic. Electrical term is not that much correct. Better one is electrostatic force of attraction. Force of attraction. Why? Due to opposite charge. Opposite charge on their ions. Therefore, ionic bond are stronger than covalent bond. Ionic bond are stronger than covalent bond. So the simple statement is ionic bond is stronger than covalent bond. But in higher standard, you will learn a bit more detail. Those things are beyond to your scope, but let me explain a very smaller thing. See, NaCl. Are you getting? So Na plus one ion and Cl minus. So it is attraction between one proton and one electron. Getting? It is like this. Another, if you consider MgO, it means Mg will form positive. So two positive, oxygen net two negative. So two positive bonded with two negative. Now which one will be stronger? It is obvious. The attraction between more positive and more negative will be more stronger. So bond between, so even electrostatic, or let me write simply the bond between, so bond between MgO is stronger than bond between NaCl. So that's why NaCl is easily able to dissolve in water and very easily the ion can be made free, but MgO not that much. Means that bond cannot be broken that much easily and ions are not that much easily free. Okay, it is one thing. If you consider the aluminium oxide, again the similar kind of mechanism you need to consider. A student, but if I consider for N2 or say O2 itself, then what is that? Oxygen and oxygen, they have the double bond. Then sometime it is possible that this double bond is maybe more stronger than double or triple. Basically, even triple bond cases, these things are holding good, more stronger than the single ionic bond. Ionic bond between the single positive means one positive, single positive and single negative ion. Means one cation, one anion, or monocation, monoanion. That is basically single positive ion, write in bracket, monocation. This thing we have already learned in class 9. आपको भूलनी नहीं रहती है पढ़ाई में, that is important. And the single anion called monoanion. Okay, it is like so. यदि आप ऑब्जर्व करेंगे तो N is stronger than NaCl. Okay, so may be possible यदि ट्रिपल बॉन्ड है कोवैलेंट बॉन्ड में तो वो सिंगल बॉन्ड जो इलेक्ट्रोवैलेंट है उससे स्ट्रॉन्गर हो जाता है. That is also possible, but these things, I mean this much details will not be asked to you. आप यदि देखेंगे तो ये जो डिटेल्स हमने यहाँ जो एक्स्ट्रा चीजें आपको बतलाई हैं ये आपको हो सकता है भी नहीं पूछे, बट आपको जानकारी बस रखनी चाहिए. इज यदि इसी स्टेटमेंट में द स्टेटमेंट इज चेंज लाइक दिस, ionic bond is always stronger than covalent bond, then that may not be true, but in general ionic bond is stronger than covalent bond. So at your level if the question is asked, you always mark ionic bond are stronger than covalent bond. Okay, that much is enough. Any more doubt then please ask, otherwise we have finished the covalent bonding. We will go for the other molecule. Let us go for the CH4. I had already drawn that. So how to finish it? Carbon have the 4 electron. Take one hydrogen. Hydrogen have only 1 electron, but this hydrogen need only 1 more electron. So one hydrogen will share only 1 electron with this one carbon. As a result, to get 8 additional electron, this carbon have to share with 4 hydrogen atom. Sorry, something, I mean, some error was that statement. To get the octet configuration of carbon means it need 4 additional electron, but one hydrogen can share only 1 electron. Therefore 4 such hydrogen are required to share their electrons. As a result, one of this carbon have to combine with 4 hydrogen to form a stable octet configuration. Therefore, the structure of this CH4 become like this. So this is the carbon, this is the hydrogen, ready? But no need to draw this much bigger formula. You just draw the line structure or just the bond formula. C is sharing single pair of electrons, so CH4, or write this as simply CH4. Is it okay? It's okay. Now let me go for the other student. Please do for C2H6. How this formula is coming, that we will learn later, but you please draw this. C2H6. Here you are getting 2 carbon is there. So 2 carbon also have to be linked with each other and other have to be filled with this hydrogen. Please do this. How could be the structure of this C2H6? Please draw in your notebook and verify with me quickly. Yes, students, start thinking. We have 2 carbon and 6 hydrogen. The criteria is for each carbon we have to count for 8 electrons, means 4 bond. It's so simple. And for each hydrogen we have to count for 1 bond, means 2 electrons. So how that can be done? See, a student, consider 1 carbon here and another carbon in adjacent to this. Let me take the 2 carbon like this. So let us draw the electron for each of the carbon. Let me draw with the cross for the second carbon. Now let us consider for the hydrogen. So 2 carbon and 6 hydrogen. So for hydrogen, I need what, only 6 are available. Means I shall associate the 3 hydrogen with first carbon and the 3 hydrogen with the second carbon. So draw the hydrogen, the hydrogen, draw this, the hydrogen, hydrogen have only 1 electron, so we may start sharing like this one, draw this structure. So up to maximum we have to satisfy them. Means we have to satisfy the octet or duet configuration. Now consider for one of the carbon. If we consider one of the carbon, here we are getting carbon and hydrogen. Say for the first one, this bond form, this bond form, this bond form, and one of the electron is already there. So if I consider this first carbon, here we can get total 6 and 1 7, but it need to be 8. For that, one of the electron have to be shared between the carbon. So this way we are able to draw the structure like this. Now for the second carbon, the 3 bonds between the carbon and hydrogen and 1 bond between carbon and carbon itself. So how is the structure, or what are the region or the controlled area? For hydrogen, it can accommodate maximum 2 electrons. So only this much is enough for this hydrogen. Now coming to the carbon, the first carbon have shared the 3 electrons with the 3 hydrogen, but one of the electron with the second carbon also. So its area or influence will be like this one. For the second carbon, again the region of influence or the area of electron will be like this one. Are we getting? So this is how the electronic structure is. For writing it in the simple fashion, what to do? The 2 carbon, so between the 2 carbon there is only 1 electron, so draw this 1. For the hydrogen, 1 bond, I mean the single bond, so draw like this. Hydrogen and hydrogen also for the second carbon. So student, here important point is that carbon can form maximum 4 bonds. Just by observing that, we can write the formula very quickly. So write that point. Carbon forms 4 bonds, which could be either between, or these 4 or sum of which form 4 bonds. So sum of which could be between the carbon or between the carbon and other atoms. Some of which could be between carbon, means one carbon and another carbon, not with the single carbon. Between always means at least between the two. So between the carbons and other with hydrogen or other or any other atom. Hydrogen or any other atom. Are we getting this much? So it is this much. So it is very important. This is ultimately the tool how we are going to apply this. So we have to once more we have to understand this for drawing the structural formula of any compound. This is the only tool. Means for carbon you have to draw the 4 bonds. Say if 5 bonds with carbon. Say I have drawn like this. Say C, H, 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 C, H, 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 and H. Is this structure possible, student? Can anyone answer? Is this structure possible? If not, then why? So if we have taken the 5 electrons or 5 bonds, then what we are observing? A student, observe this. For the first carbon, we have total how many electrons which are in shared form? So if we consider this first carbon, so it is like this one. So how many electrons in their outermost orbit? Each bond corresponds to 2 electrons. So 1, 2, another 3, 4, 5, 6, 7, 8, 9, and 10. So can any outermost orbit accommodate 10 electrons? No, it is not possible. Therefore, if 5 bonds are drawn, it is a wrong one. So it is wrong. So you need not draw the structure which contain more than 4 bonds for one carbon. So complete this. If 5 bonds with carbon, then octet rule is violated. Which is not possible. Which is not possible. Means in this case, this carbon have, so here carbon have total 10 electrons. 10 electrons or 10 valence electrons. 10 valence electrons. It is basically valence electrons, which is not possible. Which is not possible. So this is the important point that we have to keep in mind. If we are drawing only 3 bonds, if 3 bonds by a carbon, is that true? If we are drawing like this. Say, let me take C, H, and F, only these three. What is the problem with this? Why not CH3 can exist? Student, here we are observing this carbon have how many electrons? In this case, for counting the electron, each of the bond corresponds to 2 electron. So 1 electron, 2 electron, 3 electron, 4 electron, 5 electron, and 6 electron. So in this case, this carbon have only 6 electrons. Hence, octet means the outermost orbit must have the 8 electron. Not completed. So this cannot be stable, and this cannot exist, and this formula cannot exist. So CH3 cannot exist. Are we getting like this? So these are very important things. So considering this concept, the structure of any organic compound can be drawn. Those things we are going to learn. Student, the important thing is for completing the structural formula or drawing the structural formula, we need to distribute the electron between carbon and hydrogen just by counting the number of bonds. So we can directly write this structural formula or the bond formula rather than electron dot formula. So let us go for the other one. So let me take for the C3H8. Student, please draw this. I will give you 1 minute. What will be the structure, or what could be the way of drawing it? So first you need to draw the 3 carbon. And between those carbon, at least you must consider at least single bond. Whether double bond or triple bond is there, that we will see in next question. Now 8 hydrogen have to be distributed. For the last carbon, I need total 4 bond. So you start forming the 4 bond with this one. How I can form? With 1 hydrogen, 2 hydrogen, 3 hydrogen. It's okay, 3 is over. So from this 8 hydrogen, I have used the 3 one. So minus 3 hydrogen for one end. Now come to the other end. To have means this left carbon, leftmost carbon. It also need to have 4 bond. Only 1 bond is between carbon and carbon we have drawn. So take it or complete the valency with the hydrogen. So draw the 3 hydrogen here. This way, total 8 electron with the leftmost carbon, it is also over. So 3 more hydrogen is removed. Now how much is left? So we have now 2 hydrogen. We shall now try to adjust this for the intermediate carbon. So yes, this carbon also need to form the 4 bond. 2 bonds are already existing. So 2 more bond or 2 new more bond between the middle carbon and hydrogen is now formed. So this is the structure. So it's so simple. You have to practice a bit more. Okay. Let us draw the other one. So C4H10. How to draw it? So student, this organic chemistry or this chapter, carbon and its compound are like mathematics. So you have to understand like that. So C4 and H10. What it could be? Students, very simple. Take the 4 carbon. At least very first you draw the straight carbon arrangement. You go for distributing the 10 hydrogens. So last one must have the 3 hydrogens. The last one must have the 3 hydrogen that they can accommodate. So 6 is over. but this one which is in between, two bonds are already framed, so it can, or this carbon or intermediate carbon need only two more hydrogen. Let us draw these two hydrogen like this. The same is also true for this, the other carbon or this carbon. So adopt the same methodology, fill it with the hydrogen. Now count the number of carbon and number of hydrogen. You are observing that carbon is 4, carbon is here 4, but hydrogen 3 on left hand side, 1 2 3 4 5 6 7 8 9 and 10. Yes, it is 10, so it's okay. So this way carbon and hydrogen are satisfied, means whatever the required condition, it is satisfied. So this structure is correct. But some of our students may think slightly differently. He may think, why I shall put like this? He may start thinking, oh, carbon, 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 I am putting the another carbon here itself. Then also start distributing the hydrogen. Now in this case there are 3 carbon at the terminals, means at the end, which have only 1 bond formed. The other 3 electrons or bonds are free, that can be filled with the hydrogen. That is one thing. So let us fill it with the hydrogen for the end one. Yes, fill it with hydrogen. 1 2 3. For this carbon also fill it with the hydrogen, 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 hydrogen. So this much is over. Now coming to this middle carbon or intermediate carbon. What is there? How many bonds are already existing, students, here? No one can answer. 3 are already existing. Good. How much does it need more? Here 3 are existing. Maximum any carbon can form 4. So 4 minus 3 is how much? 1. So only 1 hydrogen or only 1 more new bond it can form. Then you have to count the number of carbon and hydrogen. Count it. Let me count with you. So start from here, or from here, 1 2 3 4 5 6 7 8 9 10. So here also C is 4 and hydrogen is 10. Okay, so this way this C4H10 can have these 2 structures. The first is this one and second is this one. And a student, both the structure are possible. Getting? So 2 possible structure. 2 possible structure or a structural formula for C4H10, and both are correct. So such 2 structural formula are called isomers. So what is this isomers? How many structural formula are possible? Those things we will learn in next topic. Here I have explained just how the structural formula is drawn for a given molecular formula. So it was that one only. So let us restrict to that much only. Now student, here I had explained between the carbon only 1 bond we were forming. Now if we consider C4, or let us take the simple one, C2H4, is it possible to form this formula? For this, can we draw the structure formula following the octet rule or not? Student, we have the 2 carbon. So first draw the 2 carbon. Take 1 carbon. So at least one bond is must. Later on you will think whether the double bond is there or not. Now consider here 4. So 2 carbon we have drawn. It's over. Now 4 hydrogen we want to distribute. How we can distribute these 4 hydrogen? Student, it is possible that 3 hydrogen I have kept here. So means 3 hydrogen I have kept on one terminal. How much is left? Only 1 hydrogen. Now if I am placing 1 hydrogen, so now whether the octet of both the carbon is satisfied here? Now observe carefully. For right hand carbon, we are observing total 1, 2, 3, 4, means it's 8 electron. It's okay. But now come for the left hand carbon. So for the left hand carbon, only 2 bonds are formed. Why only 2 bonds I have considered here? I have only 2 hydrogen. Sorry, I was left with only 1 hydrogen. So that's why I had given 1 hydrogen to left carbon. So in this case, what we are observing? How many electrons are there? They have shared only 2 electrons. 2 electrons are still left with this carbon. So maximum, a total 6 electrons are available with this carbon. So 2 is this one. Another we may denote like this. It was this and this. So in this case, we are observing for this carbon, if you count, how many electrons are for this black carbon or carbon on left hand side? Here we have 1 electron, 2 electron, 3 electron, 4 electron, 5 electron and 6 electron. Only 6 electron, because this hydrogen, a student keep in mind, slightly modify this structure. So for this carbon, the structure is, or the jurisdiction or the area of control is like this one. This is the area of control of hydrogen. So for this carbon, only 6 electrons. So no octet. It means the above structure is wrong. It cannot exist. So is there other way of drawing the structure or rearranging this carbon and hydrogen to draw the stable structure where each carbon have their octet configuration and hydrogen have their duet configuration? Let us search. A student, by the way, if you are thinking this way, say the 2 carbon is there. First, let me take a single bond. Now 4 hydrogen is there. Let me give the 2 hydrogen to each carbon. Means I am going to give the 2 hydrogen to this one and 2 hydrogen to this one. Okay, student. After this structure, what we have? If we consider the left carbon, we have 1 electron, 2 electron, 3 electron, and total 4 electron it have, but 3 are being get shared. So these shared are with like this one. These are the shared, but 1 is still free. Okay, now let us come for the right hand side carbon. It also have the 3, total it have the 4 electron, but 3 electrons are now shared. 1 electron is still free. Coming for the hydrogen, we are getting hydrogen have no problem because it always forms the single bond. Hydrogen side there is no problem, but for this carbon we are observing, it is possible that the electron or unshared electron of 1 carbon will be shared by unshared electron of the second carbon. So this way, these 2 electrons will also come closer and they will form one more bond. So what will like that? So it will appear like this. Okay, the new is which was considered as unshared, it have formed one more bond. Now, student, now please count the number of carbon and hydrogen. So for the left carbon, what are the area of control? So it is up to this much. For the right carbon, what are the area of control? So up to shared, it also have to go. So it is up to this much. Okay. So how is the structure? So the structure is like this. The carbon and carbon, between them there is double bond, and with this hydrogen and hydrogen, hydrogen and hydrogen. So in this case we are observing each of the carbon have 8 electrons, means it's okay. Each of the hydrogen have 2 electrons, so it's also okay. So this way the octet is satisfied for each carbon. So for each and every carbon, the octet configuration have to be completed. And duet for each hydrogen. So this way, this is a stable structure. So it is a stable. Or this structural formula is correct one. Are we getting? So it's adjust. So this structural formula is correct, but this structural formula, if anyone is drawing like this, it becomes wrong. So distribution of hydrogen have to be done carefully. So first we shall anticipate whether double bond or triple bond is possible or not. So those things we will learn in our next class. A student, let me draw one more structure. Consider for the C3H6. Take this one. Draw it quickly. A student, we have the 3 carbon. First draw like this. Now go for the hydrogen. We have only 6 hydrogen, so start distributing. If you are distributing the 6 hydrogen just at the end, like this one, then coming to the middle carbon, we are observing only 2 bonds are formed, but this carbon also need 2 more bonds. So this structure is wrong, because in this case octet for the middle hydrogen is not completed. So what to do? I need to rearrange this hydrogen. So how I can rearrange? A student, I can rearrange in many ways. How is that? Say I am removing this hydrogen and going to make the bond here. Then while one of the hydrogen is removed, this hydrogen also need to form the bond here. So observe what could be the correct structure. Say if I am taking these 3 carbon like this, I have to distribute 6 hydrogen. So for that, if I am putting the 3 hydrogen at one of the carbon, let me put, I cannot put other 3 on the other carbon. Otherwise, the intermediate carbon cannot form the 4 bonds. So I need to form a double bond between the 2 carbon first, then I shall try. Now while the double bond is formed, in this case, coming for the middle carbon itself, how many bonds are already formed and how many more bond it needs to form? A student, 1, 2, and 3. 3 bonds by this middle carbon is already formed. But it needs to form one more bond. So that total 4 bond should be formed by the middle carbon also. It means it needs only one hydrogen. Okay? If this one hydrogen is given, then how is the structure? Let us see. So this hydrogen, let me make it permanent. This hydrogen I have given. So 3 hydrogen I had already given to the left carbon. One more hydrogen I have removed. Now I am left with only 2 hydrogen. So try to give these 2 hydrogen for this carbon. So give this 2 hydrogen. Now observe whether the last carbon is also satisfying the octet rule or not. Means last carbon need to form the 4 electron and whether they have formed that much or not. Observe it. Means observe for this carbon. Here we are observing how many bonds? 1, 2, 3, and 4 bonds are formed. Means this last carbon also have 8 electron. So this way, this structure is correct. So this way you have to slightly anticipate. First you have to practice. So student, let us finish it. How is the structure? So just drawing this much is enough. No need to draw the circular or area for this carbon and hydrogen. No need. Only this much is the correct answer. So if the structural formula is asked, unless or until electron dot formula is asked, if only a structure formula is asked or bond structure is asked, this much is enough. So here we are observing that between 2 carbon there is double bond. So write down the few remarks here. So double bond, and between these 2 carbon there is single bond. Okay, these are also, so this is the single bond between 2 carbon. Here double bond between 2 carbon. Okay, and these are the single bond between carbon and hydrogen. Okay, so such an organic compound which contain double bond, at least one double bond, is called alkene ENA. This we will learn later in more detail. Are you getting? So this way we cannot go to the next topic, but at least we have finished some important concept or some how to draw the structural formula and how is the bonding of carbon with all other elements. A student, let me draw the last one. Let me draw for say CH2Cl2, whether this is possible or not. Exactly the same as CH4. A student, only one carbon, draw one carbon. But carbon need to form 4 bonds. I have 2 hydrogen and 2 chlorine. We are knowing that hydrogen can form the single bond only. Chlorine also need to share 1 electron. Yeah, either gain 1 electron or share 1 electron. So chlorine can also form only 1 bond. So at 2 places, I shall complete with hydrogen, and at 2 other places, I shall give the chlorine. You may draw the electronic structure by drawing the 7 electron for chlorine, then sharing 1. Okay, that way you can also draw. So writing the structural formula is very easy. With all this, take the homework. Draw the structural formula for following, or bond structural formula and bonding. Bonding means whether single bond, double bond, those also you have to write for following. Students, you please first take the CH3Cl means the same as above. In place of 2 Cl, only 1 Cl, H will be the 3. C2H5 and Cl, like C2H6, 5 Cl you have to give and 1 chlorine you have to give. The third one, C2H2Cl2. This you have to draw. The fourth one, C2 and H2. Whether this is possible or not, you have to draw. It will be alkene. I may discuss next. Then draw the C3H4. Then the next one, C4H8. Draw one more. C3H6. In place of 6, write 4 and Cl2. Okay. Draw only this much. Student, for your just understanding, let me explain a bit more. Perhaps you may be thinking how this is possible to form C2H2. This structure. Student, see, we have the carbon and carbon. Means the single bond will be surely there. 1 and 1 hydrogen. The better way, if I am giving the 2 hydrogen here, then we are getting that none of the carbon is able to complete their octet. So this way of thinking is totally irrelevant or not correct. So I shall start thinking other way of distributing this hydrogen and drawing more bond between carbon and carbon. So if I give 1 hydrogen and 1 hydrogen here, then still this carbon have, say left carbon, have shared only 2 electrons. Still it have 2 more electrons. Also the right carbon still also have the 2 more electrons. So this other sharing is also possible. Correct? So it could be this one. Ultimately, it is like this one. So the structure is like this. It is our C, the other C, the 3 electrons are shared with their adjacent one, and one of the electron is shared with the hydrogen. So draw like this. So this is the other bonding. So if we draw the structure, it is like this. Sorry, it have gone to this much because this is also the electron of the carbon. So the structure is now completed. Draw like this. Sorry. So it is like this. Is it okay? For the hydrogen, you also need to complete the structure. Keep in mind, for hydrogen, you need not do like this. Otherwise, it will go in the region of the other carbon. So you should be careful while drawing the structure. So for hydrogen, the electron sharing is up to this much. So you must keep it outside. Do not cross with the region of the second carbon. Okay. So it is like this. So it is the structure. So in the bond structure form, H, C, triple bond C and H. So this is the structure. Similarly, you have to do for the C3H4 where triple bond is existing. So such a compound where there is triple bond means 3 pair of shared electron or triple covalent bond. Okay, so such compound is called as alkyne. So whatever the terms that is coming, you please start learning or keep in mind at this stage. Later on we will learn in more detail. Okay student, so this was all about today class. Let us stop it. We have not gone to the other property like allotropes and catenation. That we will do tomorrow. But I had explained how to draw the structural formula, how the covalent bonding, what are their properties. So please practice this. Okay, thanks student. But आप लोग मन से पढ़ाई करिए. My request is that, because if you are not focusing toward your study, then that will reduce your marks. So first you need to revise